Hi everyone! Today we're going to evaluate definite integrals by substitution. Let's have this example 1. Evaluate the integral from 0 to 4 2x times the square root of the quantity x squared plus 9 then dx. For our solution, let us rewrite this integral showing the radical to be fractional exponent. And from here, let us choose u. We let u to be this x squared plus 9. So du is equal to 2x dx. Let us now substitute these values to our integral. So we have this x squared plus 9 to be that u. Now we put the exponent 1/2. And this 2x dx is equal to du. Now let us evaluate the integral. Using the power rule, this u raised to 1/2 is now equal to u raised to 1/2 plus 1 all over 1/2 plus 1. The 1/2 plus 1 is 3 over 2. So we write u raised to 3 over 2 all over 3 over 2. Let us simplify this fraction here by flipping it up, making this denominator 2 be coefficient of the numerator. So we have 2 times u raised to 3 over 2 all over 3. From here, let us return the value of u with respect to x. We have this 2 times the quantity x squared plus 9 all raised to 3 over 2 all over 3. Now let us evaluate this with regard to our limits of integration with this 4 and 0. Starting with 4, we have now this expression minus this function evaluated by 0. Now let us simplify. This 4 squared is 16 plus 9 is 25. The 0 squared is simply 0 plus 9 is 9. So we write here 9. This 25 raised to 3 over 2 is simplified into 125, while this 9 raised to 3 over 2 is 27. 2 times 125 is 250. 2 times 27 is 54. We get the difference of the two like fractions. We have this 196 over 3. This is the final answer. Example 2. Evaluate the integral from 1 to 2, 6x squared times e raised to x cubed plus 1, then dx. For our solution, let us choose u to be that exponent of the e, the x cubed plus 1. So du is equal to 3x squared dx. Observing our function 6x squared, while here 3x squared. We want this 3 to be equal to 6. We will multiply this equation by 2. So we have now 2 du is equal to 6x squared dx. Now we are ready to do substitution. We copy the e, and the x cubed plus 1 is the u. So we see here e raised to u times the 6x squared dx is now replaced by 2 du. We have now this new integral of eu times 2 du. Let us simplify this first by putting the number 2 outside the integral sign. We have now 2 times the integral from 1 to 2 eu du. We know that the integral of eu du is simply eu. So we write 2e raised to u. Returning the value of u from here, so we have 2 times e raised to x cubed plus 1. Now let us evaluate this with respect to the limits of integration from 1 to 2. Starting with 2, we have now 2 times e raised to 2 cubed plus 1 minus 2 times e raised to 1 cubed plus 1. This 2 cubed plus 1 is 9, so we have 2 times e raised to 9 minus this 1 cubed plus 1 is 2. So we see here 2 times e squared. We can factor out the number 2 from each term, so we have 2 times the quantity e raised to 9 minus e squared. This is the final answer. Example 3. Evaluate the integral from 1 to 2, 2x dx all over x squared plus 2. For our solution, let us choose u, that is the x squared plus 2. So du is equal to 2x dx. Let us now substitute these values to the integral. So we have now the integral from 1 to 2, our denominator x squared plus 2, that is the u, while the numerator 2x dx, that is du. The integral of du over u is simply the natural log of the absolute value of u. Let us return the value of u, which is x squared plus 2. So we have the natural log of the absolute value of the quantity x squared plus 2. Let us evaluate this with respect to the limits of integration. Starting with 2, we have now the ln of the absolute value 2 squared plus 2 minus the natural log of the absolute value 1 squared plus 2. This 2 squared is 4, 4 plus 2 is 6. So we have ln of the absolute value of 6 minus the 1 squared is 1, 1 plus 2 is 3. So we have the natural log of the absolute value of 3. Since we see here that the values 6 and 3 are both positive, we can remove the absolute value symbol. So we have this ln of 6 minus ln of 3. This is the final answer. I hope you learned something from this video. See you again next time.